Good afternoon. My name is Robert Bond. I'm a mechanical engineer with analytical and combustion systems. And today we'll be doing a webinar regarding the electrification of the boiler room and some topics surrounding that. Today I'm joined by David Oaf. And David, you want to introduce yourself?
Yeah, I'm David Oaf with Preferred Utilities. I'm a mechanical engineer that's worked in combustion for boilers in the electric utility industry for about 35 years.
And I also have Patrick here with me, Patrick McCarty.
Hey, I'm Patrick McCarty with the Lexus Engineering Group, mechanical engineer as well. I've been working in the HVAC systems for buildings for about 10 years, and I just want to thank Robert for having me on.
So I work here mainly in the New York City and Northern New Jersey and Long Island area doing system sales. We're Preferred Utilities local rep here, and we also service a lot of, we're Johnston Boilers representative and Superior Boiler as well. So we do a lot of combustion systems and have been for the past 30, 40 years, mainly in the tri-state area. So we're very involved and aware of the New York City and New York State climate goals and agenda that they're after. And that's kind of how I met Patrick McCarty here. And he is sort of on the forefront of the push to move from fossil fuels to electrification. And that's one of the main reasons we wanted to have him on as a special guest here. So Patrick, can you tell us a little bit about how these sort of opportunities, and so what's pushing clients of yours to get on the grid and go electric with their heating systems?
Yeah, so thank you, Robert. So a lot of the push in New York State and New York City is to meet the Climate Leadership Act that New York State is a part of. So these goals essentially are for the future. So in 2025, they want to reduce the emissions by 85%. And then also in 2040, they want all electricity to be from renewable energy. So there's a push from the state and especially the city. They enacted Local Law 97, which essentially there's covered buildings that need to hit emission goals, or they're going to essentially be taxed on their carbon emissions that go over the cap. So that's what we're kind of seeing, and that's kind of what we're seeing the push from our clients. There's a push for building owners to be more environmentally friendly with all of their carbon emissions coming from their buildings.
Yeah, we're definitely seeing that too from when we walk in and we're dealing with end users that are looking for alternatives or more efficient equipment to help lower their carbon emissions. But yeah, okay, so that's sort of where it's coming from. And David is located in Dallas, Texas. David, are you kind of seeing this in the rest of the country, or is this sort of a local thing?
The only other place that has the same sort of focus on carbon, I would say, is California, and to a lesser extent, Oregon and Washington. But California is probably second behind New York as far as wanting to reduce carbon emissions.
Okay. All right. So yeah, I mean, that's New York's sort of leading the charge, and yeah, so that's sort of what's going on and what we're seeing on the ground here. But again, yeah, the mission is to to shift, and there's a push to shift from fossil fuels to electric heating. So obviously, with different building owners and different manufacturing processes and companies, there's going to be a different fit for each person or each company for what they're looking to do. But the end goal is to reduce their greenhouse gas emissions. And I see that one of the main things that I hear my clients and building owners talking about is they're looking to heat pumps sort of as their main, as far as technology, the main thing that they can switch from a boiler, traditional fossil fueled natural gas or diesel fueled boiler, to switch from that to a heat pump. Is that kind of what you're seeing as well, Patrick?
Yeah.
I'll just say the traditional New York City building that we think of.
Yeah, definitely. Yeah, so air source and water source heat pumps is a big push for those right now, especially in New York City because they take up space, but they're not taking up a tremendous amount of space. Um, they can be installed outside, so you could put them on your roof. A lot of buildings have some space on the roof where they can put these units. So those are mainly the what we're seeing is the air source and the water source heat pumps.
So they're not looking at a major capital expenditure from the upgrading their building necessarily, or I guess that kind of depends on the building, right?
Yeah, it all depends on the infrastructure of the building. It also depends on the amount of electrical service they have. So
Right.
a lot of these buildings, when we're looking at doing these upgrades for the air source heat pumps and the water source heat pumps, we have to look at your electrical service and make sure that your existing service can handle the additional electricity that we need for these units.
Yeah, and that kind of goes into that's where I have seen some projects die. So we represent a line of electric boilers, and we've done a couple different studies, or I've been a part of studies that engineering consultants like yourself are doing for clients. And I size the boiler, I give them all the electrical capacities that they need, and then that's sort of the last I hear of it. And then I follow up with the consultant, later on, and this was the price of the project and the equipment, but then we got the letter from the utility of what it would take to upgrade their utility to the building, and that's what blew the budget on the project. I mean, do you see that in some of the projects?
Yeah. I mean, that's mostly what you see is you need a service upgrade from the utility, and it's expensive. And there's no way to get around that.
Yeah, and especially where we are, where it's sort of some of the oldest utility infrastructure in the country,
Right.
where it's not easy to just replace what they have. And we're kind of pressed for space anyway. So
yeah, you're pressed for space, and sometimes you need to put a new transformer, switchboard inside the building. You need to find space. So
right.
sometimes there's some additional space that you need as
Right.
well.
Right. Now, do you see a lot of incentives coming along with the switching to electric, or is it not? Is the state, New York in specific, are there some good incentives behind it?
Yeah, there's some really great incentives. So NYSERDA teams up with Con Edison and the other utilities too in New York State, PSE&G. And essentially there's an incentive called Clean Heat, and it's essentially for the air source and the water source heat pumps for heating of the building, and also domestic hot water heating as well, where they give you can look it up online, look up Clean Heat through Con Edison, and you'll see the incentives that they'll give you for your type of building. There's all different types of categories depending on what type of building you are. But there are some really, really good incentives to do these projects.
Okay. And then once the project is done, your operating expenditure, you're essentially tied to the utility, and kind of I guess they can give you a better rate, to incentivize you to do the project. I mean, I have dealt with some clients that do get that, correct?
Correct.
Yes. Yeah. Okay. One of the challenges, again, that I have heard, it's not just here in the Northeast. I know David has had some cold days down there in Texas too, but the performance in cold climate conditions, obviously, heat pumps do not do as well. Their efficiency goes down. I mean, that's pretty well documented and everything. But I mean, from what I've seen, I mean, you're really only looking at a couple weeks out of the year where you're going to have some, bad performance out of your heat pumps. Is that kind of correct? You don't see anyone really shying away from heat pumps because of the cold climate, or is that not the case?
Yeah, heat pumps now, they go down, most of them, the major manufacturers, the heat pumps will go down to 0 or even -10 degrees.
Okay.
But their capacity starts to drop off. And when I say capacity, that means the amount of heat they can actually put out into your system. So about from 30 degrees, so it's 30 degrees ambient. I'm talking about air source heat pumps now. So if it's 30 degrees ambient, and you want to go down all the way down to say 10 degrees ambient, you have a drop off of about 50% capacity.
Really? Okay.
So
That's pretty significant.
yes, it is very significant depending on the outside air temperature. And during heating, obviously, when it's colder outside, you need more load to heat your building. So it has kind of a double effect.
Right. And if you don't have a good safety factor on how many heat pumps you put in your building, you could be heating your building 50% less and have some pretty upset clients.
Right. So
in
you're
the
going to
building.
need
Yeah.
some sort of supplemental,
hmm
or if you're going to install all of it being electric, now you have another issue where your electricity service that you need for the building starts to almost become unfeasible
Mhm.
for an existing building, just for the space requirements and, you know, the service from the utility. So you really have to be careful when you're looking at heat pumps to make sure that um, you're not installing all the way down, I would say all the way down to that design temperature. To install it somewhere kind of in the middle, and then you go with the hybrid approach, which is you have a supplemental some sort of gas or fuel oil fired boiler.
Okay. Yeah, and we'll definitely talk about that later. So that is the hybrid approach, and
Heat pumps
Yeah.
are available with electric resistance heating too, at least on residential size heat pumps. Is that true of commercial size heat pumps too?
Yeah, they do. The thing about the electric is essentially, electric resistance coils only have an efficiency OP of 1.
So it's a crazy amount of electricity.
It's a crazy amount of electricity is what I'm
Okay.
trying to say, right? So
Right.
it doesn't become too feasible to do that, just because of how much electricity you're already pulling with the heat pumps. And then if you wanted to use electric, it's even more electricity.
Okay,
So,
and on a very cold day in New York City, everybody's going to be pulling more electricity off the grid.
yeah,
Right.
so actually, right now, the main peak of electricity is, you would think, is during the summertime, right? But since everyone's going to switch or trying to switch to electrification for heating, actually there's going to be more electricity used during the winter time, which is something weird to say, but the load will actually be higher during the winter than it will be during the summer.
Wow.
And that just has to do with essentially your air source heat pumps, your efficiency starts to drop off as ambient also drops off. Also, you start to lose capacity. But as your efficiency drops off, you essentially are using more electricity to make the same amount of heat.
I feel like that lower ambient temperature limit for heat pumps has been going down over the decades. Is that the case?
Definitely has, yes. Yeah, so like probably 10 years ago, a lot of the main manufacturers, they only went down to like 10 ambient, and now a lot of them are down to like 0 and -10. So they definitely have dropped
Bear with me.
significantly.
It's been a long time since I took thermodynamics, and I think I only got a C. Are we getting close to a thermodynamic limit, or is this something that with continuous improvement that in 10 years we could see heat pumps that are good to negative?
I believe they make heat pumps that can go down to -20. It's a very specialized heat pump.
So this is the case where technology could eventually catch up and be able to supply New York City on the coldest days.
I think
It just becomes a matter of consumption.
it becomes a matter of consumption, and then it also becomes a matter of cost. Because these systems that are getting down to these lower temperatures, they're using higher pressure refrigeration cycle systems with more expensive components. So it starts to become a capital cost issue because the upfront cost to install these becomes very expensive. So those are more of like specialized heat pumps.
That's interesting.
All right, so now we can talk about the emissions portion of it. We mentioned earlier that that's sort of one of the major pushes is to eliminate, the individual buildings' carbon footprint or reduce it significantly. So, I'm very familiar with, I'll just give an example for a cut sheet for an electric boiler that I remember seeing that it says on-site net zero. So you're just really transferring your carbon footprint from the site to somewhere else. However, the incentives and policies are in place for that. And, that's why people are going for it. So you're transferring it essentially to the utility, the way that I see it. But eventually we're probably going to see the utilities hopefully get greener. I mean, we do have, we'll talk a little bit later about the mix of energy and where it comes from, and what the percentages are that we see. But it does look, I mean, there's definitely a push to go more renewable and sort of less reliant on fossil fuels from the utility perspective. Is that kind of what you guys are seeing as well? Yeah.
Yeah, Con Edison put out a report where they actually wanted to, or they're pushing for to be fully to make their electricity fully renewable by 2040. So that's kind of Con Ed's goal.
Okay.
If we'll see if that happens or not, but that's their goal that they have they've published.
Okay. Yeah, so we'll see how that goes.
Rooftop solar is commercially available and is economical. It just depends on the population density. If you live in the suburbs or you live in rural areas, there's few enough people and there's enough sunlight. There's probably plenty of resource available there to fuel everybody's electrical needs. When you get into densely populated urban areas, there just isn't enough rooftop area per person to satisfy everybody's needs. But California is actually on their second generation. I listened to a talk by the Cal State University system, and they have solar systems that are 30 years old that when they were installed put out 100 watts per panel, and now we're up to over 400 watts per panel. So they're looking at retrofitting these and getting over 4 times more electricity from the same amount of rooftop space. So that's exciting in California. In New York has the advantage of being kind of a late adopter in this, and they're going to be putting in very high output solar panels for their first generation.
Yeah, so that'll definitely help. So we did talk quite a bit about heat pumps there, but I did want to mainly talk about air source seemed to be the most popular, and I mean they're the most easy to install from a construction standpoint. And then you had mentioned that the efficiency does significantly drop off when you get sort of below or close to the 30-degree ambient temperature for most, I'd say, manufacturers, commercially available heat pumps out there.
The VRFs are usually for smaller, like not larger facilities, are usually for smaller facilities.
Okay.
And all you do is you just connect each of the condenser, which is your heat pump, is connected to the evaporators inside of your space.
And what's VRF stand for?
Variable refrigerant flow. So there's an inverter on the compressor that essentially modulates the speed. So normally, like refrigeration cycle back in the old day, they had like a bypass just going around the compressor.
Okay,
it's
now
called
you
unloading.
Slow down the compressor.
Yes.
Oh, okay.
Yeah, just like a pump would with the VFD.
What size units are those available in? What's the cutoff?
They go up to like 20 tons, 30 tons.
Okay.
Yeah. They don't get like huge. They're not going to get like a massive VRF. They're relatively small, and they connect to about like 5 evaporators inside of your spaces. So you can have like a evaporator inside of here. One of those wall-mounted units, and it has like a little fan in it.
You slow down that compressor and you get massive electrical savings.
You get savings, right? Because you're not just bypassing the gas. And then what they also do is they move heat around. So heat pumps are just moving heat around, right? So they're just taking heat out of this. If it's in cooling mode, they're taking heat out of the space and dumping it out into the environment. That's why it's not like a boiler. It's not creating heat. I mean, the compressor can produce a little bit of heat, but it's not like a boiler where you're creating heat. So what these things can do in a series of valving, they can essentially, if this space needed to be heated and that space needed to be cooled, it opens valves and closes valves in order to take the heat from that space and put it into here instead of dumping it outside.
Just by mixing.
The refrigerant will flow and take the heat from that space and put it into here. So that's what it does. And it's super efficient because you're not dumping the heat outside. You're essentially putting it into the spaces that would need the heat. So you're just moving heat around.
All right. So we talked a little bit earlier about heat pumps and about how efficient they are, and that's very well documented. And then as the ambient temperature will drop, the heat pumps will derate as you get lower in temperature. Obviously, when you do go fully electric, if a building owner were to do that, you are dependent and even more attached to the utility than ever for your cooling and heating. And smart building controls really does help an end user monitor that, and hopefully stay under their peak load kilowatt price. So if you were 100% electric, you might be a little worried about getting close to that peak demand. And if you had a hybrid approach, you could probably avoid it using some of those controls. And I mean, I don't know if you guys have seen some of that out there. David, you and I had sort of talked earlier about the different approaches that people have and the different controls that are out there. And I think some of the utilities do also sort of incentivize people to monitor that.
In some of your technologies, you have a choice of burning electricity or burning fuel. So chillers are a good example. Usually they run on electricity, but you can do direct fired chillers too. And a building automation system can be watching your peak usage. And if you're about to get into that next step change in peak charge, it'll prompt an operator to go start up your gas fired chillers and take some of the load off of your electric to avoid that huge peak. And that can be a big cost saver for
so Patrick, you had mentioned a little bit earlier about how we might start to see the largest load for the utilities switch from being in the summer to potentially being in the winter, and that's a direct correlation to all the people switching to heat pumps and other electrified heating and cooling sources. I mean, what we've heard from certain utilities is let them know as soon as possible.
Yeah, I've heard some staggering numbers about how much more electricity Con Ed is going to have to generate and get into New York City.
Mm-hmm.
And their response has been to users is, if you're putting in heat pumps or another technology that's going to increase your usage a lot, just let us know as soon as possible so we can plan for it.
Okay. All right. So I just wanted to quickly, go over some numbers that I've seen about our current, U.S. mixture of what we're seeing is the producers for utility. Obviously, natural gas is the major one at about the high 30. I see 38%. I've seen other numbers that are in the low 40s. Petroleum, crude oil, and natural gas power plant liquids in the low 30s. Coal at 11% or the low teens, and then renewable and electric are both under 10%. So that's kind of what we're seeing, from the numbers that we're getting from the government. But unfortunately, renewables is a lot lower than I'm sure we all would want it to be, and we're still heavily reliant on natural gas and oil-based, utility fuels. We've heard a lot of talk from utilities about starting to blend in hydrogen. When it comes to controls and combustion, all that's sort of been proven out before. David, can you speak a little bit about your experience with hydrogen and renewables going back, a couple decades? And
Sure. Chemical plants and refineries have been producing hydrogen for as long as I've been in this industry, going back to the early 90s and probably before that. And hydrogen is just a normal byproduct of chemical plants and refineries. So the combustion industry has been burning hydrogen for at least 30 or 40 years, and it's difficult, and it certainly has its challenges, but it's old technology now. Actually, pure hydrogen is easier to burn than a blend of hydrogen and methane, because the hydrogen wants to hog up all the oxygen. So those burners are a little bit more difficult, but it's a proven technology, and combustion engineers have a lot of experience with it. We get a lot of interest in hydrogen nowadays, and the first question I always ask people is, what is your source of this hydrogen?
right.
And if they tell me, it's the Valero refinery, across the street from us, then I know this is a real inquiry. If nowadays, if people are saying, well, we're going to get it through electrolysis, then I know this is an R&D project. Because electrolysis is really just using the hydrogen as a battery. You put a lot of electricity in to separate water into hydrogen and oxygen, and you get that energy back when you burn it. But you're not making energy. You're just storing it temporarily. and transporting it.
Okay. Yeah, and I mean I've heard some difficulties, regarding not just the where to get the hydrogen, but the actual infrastructure into getting it into the utility, because I know the molecules for hydrogen are obviously a lot smaller. You can't just use a regular natural gas pipe for pure hydrogen.
Yeah, and there's a lot of talk these days about blending small amounts of hydrogen in with the natural gas and putting it on the grid. I don't know of any place that's actually doing it yet.
Okay. And then biodiesel, I would say on the smaller individual end user side, Patrick and I in New York City at least have seen some talk about biodiesel. I mean, I know that I personally have been involved in 2 projects where we have a customer. It's a total of 8 burners for it at each individual site where we are burning 100% biodiesel. It's been going on for about 4 to 5 months, and it's been very successful. I know Preferred Utilities has been burning it at their manufacturing plant for, I'd say, about 1.5 to 2 years. It's a very cool flame. A B100 actually burns, and it almost looks blue in the center, which looks like a gas flame, which is very strange. And we've got some very cool and exciting emissions numbers out of it, including when we started using FGR, we got the NOx down, I believe, to the low 40s, which was very encouraging.
Almost natural gas type numbers.
Yeah, it's really it's exciting. That the semi-frustrating thing is, like, we have this cool technology, we have a fuel that's readily available, but the end users don't really want it. And Patrick, as far as like incentives and local law 97, we can talk specifically about New York State and city. Like, is biodiesel not seen as a option for a customer?
It's looking like in New York City, biodiesel really isn't being considered for buildings. As through local law 97, they don't actually list biodiesel, so it doesn't seem like they're being considered in the city. In the state, DOT has written reports and published reports stating that they do want to change their infrastructure for their trucks to run on biodiesel. So that's kind of like an interesting way to bring a lot of that fuel into the state, and eventually get into buildings, potentially for buildings to also burn, making it feasible.
Yeah, and I can attest to there are certain challenges, especially with using 100% biodiesel. There are, I know it's I believe it's mandated in New York City that they have to use blend. I think they're at B10 or B15 now, that is blended into their regular diesel. So I mean, that up to B20, it is a drop in 20% biodiesel. It is a drop in fuel. When you go above B20, there's a lot of data to support changes that you're going to have to do in your piping, different valves, the burners. And I know Preferred Utilities has been working closely with UL, and Preferred does have I believe it's the first commercial and industrial B100 rated burner from UL. So that was recently announced, I think about a month ago. But yeah, we have this product, we have this fuel, and there's no real push to start using it yet, I guess, until DOB maybe, or the state, I guess.
Yeah. I think the beautiful thing about biodiesel is you keep a lot of your existing infrastructure that you have. You don't have to do major infrastructure changes that you would like if you did electrification. And it's renewable energy, right? You're using essentially fats from animals, oils from seeds. So it's all organic materials that you're going to be burning that otherwise would have just been exposed into the environment.
Right.
It's a good way to save on upfront capital and also reduce your carbon emissions for the building.
Right, and a couple other things I remember, because I do have a separate presentation on biodiesel, is that it's non-hazardous. So if you ever spill it, it's a non-hazardous item. And then also that when people think of biodiesel, I'm sure it's an end user that pays the bill. You're going to think of the cost, but biodiesel, 100% biodiesel tracks pretty much exactly over the last 10 years with 2 oil. It is it's I'd say about 5% more expensive, and it has a little bit less BTUs per gallon. But the price is there. It's readily available. It's just sort of not seen as an option quite yet.
And the technology is all there.
Right.
Most
Yeah.
most of the small capital cost to switch over to biodiesel is we need to get the brass and bronze out of your fuel line, out of your burners, and we need to get the rubber seals out of your pumps and your other components. So it's a little bit like when cars switched over to ethanol, we had to replace some of the components of the fuel lines. From a combustion point of view, biodiesel is not difficult. We burn a lot more difficult fuels than biodiesel.
Right. Yeah. And again, that's only once you go above B20 in the blend that we start to see those issues. Below that, it's so far has been a drop in fuel replacement.
Yeah, definitely looking into, helping your envelope of the building, making sure there's not as much heat transfer, is always going to help reduce essentially your load on your new equipment, which will help with your, following that, which is your electrical loads. So always doing that first, looking into that. I think NYSERDA has programs in New York State that help you do evaluations and also give you incentives for doing building envelope upgrades. So that's something that should always be evaluated.
Yeah, and obviously it's best to go after the low hanging fruit first, like the lights and the insulation and the windows as well.
Yeah, lights
obviously.
Are a no-brainer.
Right.
Lights always have a great ROI. So
right, and that's been again around for a long time. But as far as I'd say the hybrid approach that we were kind of talking about. The nice thing, when we're looking at retrofitting, is a lot of them, especially in again, you and I can speak to New York City, is like they have that boiler room in the basement already, and if you're going to keep it, or you can even downsize if you're going to go with the modular approach, the hybrid approach. You could go part heat pump and keep that room, or even use part of the room maybe for a heat pump application.
Yeah. So definitely the hybrid approach is the approach that I see a lot on the projects that I'm working on, and a lot from the client side too. When you do the feasibility of going full electric, like we stated before, it starts to become a tremendous amount of electrical load, and also utility costs too, because as you're dropping in efficiency of your heat pump, you're also using more energy. So your COP drops and your utility bill will go up for electric. So it's definitely a case by case analysis that needs to be done of your building to see what approach is appropriate. But the hybrid approach has been the approach that most engineering firms have been taking, building owners have been taking to get that building more electrified, or electrification for the heating systems.
So obviously, when talking with any building owner about doing an upgrade and looking at what budget they have available, the construction cost and timeline is always a key factor of that. Assuming that we've already gotten past the phase of we know what the utility upgrade is going to be. We have the incentive. Some of the construction costs that I've heard from some consulting engineers and contractors is that the cost can be 5 to 10 times what a traditional, if it was just going to be a like for like boiler replacement, upgrading a 30 or 40-year-old boiler room that's a mess. You could clean the room, epoxy the floor, drop in new boilers, new lines, and that usually those boiler projects take a year and a half, maybe two, if it drags on a little bit and you have some challenges. But you kind of know what your costs are, and a lot of the infrastructure is already there. Some of the stories I've heard with electrification projects are, like I said, 5 to 10 times the cost, and 5 times the time that it takes to actually complete a project. I do know of a couple boiler replacement projects that were completed way ahead of another project that was going sort of in parallel with a job, and it kind of blew my mind. But is that something that you're seeing as well, or I mean, is that?
Yes, because most of these projects you need an electrical upgrade.
Right,
So now
yeah,
you're dependent on the utility.
Yep.
Whereas if you were just doing a replacement in kind and upgrading the boilers, essentially you're doing it without the utility. So you can do that on your time.
Right.
Whereas when you have to involve the utility, now you really need them to come in as quick as possible and do the service upgrade that you need. So you're kind of dependent on them, so that can really blow up the schedule of the project.
Mm-hmm.
And also the initial construction costs, like you were saying. When you do these types of electrification projects, new infrastructure, when we say new infrastructure, we mean conduit, riser, feeders, going up the building if the equipment needs to be up on the roof. So this can become, extremely costly. You're disturbing your building while you're doing this as well. So you have to take that all when you're doing these projects.
Right. And then let's moving past the construction phase, when we get into the operational costs. Obviously, natural gas and oil isn't, well, David, out where you are, natural gas is pretty cost effective.
It's very cheap. It's under us all in DFW. It's just a matter of getting it above the ground.
Right. So there are obviously areas of the country where natural gas and oil prices are very, I'm not gonna say they're ever cheap, but they're lower. They're lower than they are here. I can say that. But electricity here is very, very expensive. I have my Connecticut rates, and I know the rates Patrick was telling me earlier are significant.
They're significant. Yeah. It's expensive.
So, I mean, your operational cost, that is something that obviously has to be looked at very closely by an end user and the consultant to make sure that, after you finish this upgrade, you're not only feeling good about yourself about, helping out the environment and, reducing your carbon footprint and all that, but it's got to make economic sense as well, obviously. I know incentives do help with that, and there are rebates. And then, a life cycle, cost analysis, which I'm not super familiar with what, the heat pump, life cycle is. I assume it's, is it close to what, I mean, the boiler properly taken care of with proper water treatment, which we rarely see proper water treatment, but, they can last 40, 50 years, if properly taken care of.
Yeah, I would say heat pumps
yeah.
is a little bit without a major rebuild. The compressors probably have to be replaced within 20 to 30 years.
Okay. Yeah.
So
they're a lot like air conditioners. It depends on how hard you run them.
yeah.
If you run them really hard, you're going to replace them quicker than you would expect.
Right.
Yeah, when you're running them at certain temperatures too, you start to get frost on them, and then it has to do a defrost cycle. So up here, when it's humid and colder, they have to run a little bit harder.
Okay.
So up here, they do run a little bit harder than, say, if you were in an area where not as much humidity.
So our next bullet point is cold climate tech or backup is needed. And we talked about natural gas fired hot water boilers as a backup to heat pumps. We're all engineers working on critical infrastructure, so we need to design for all cases. And it sounds like when it gets down to a very cold ambient, and I just looked it up, the record cold in New York City was minus 15 degrees F in 1934. So they've probably been recording temperatures in New York City for 400 years, and the minus 15 was the lowest. It's probably safe to say it goes below zero once every 100 years. We have to design for that case. And it sounds like the heat pumps lose efficiency at that temperature, and most of them are going to be in automatic. So as the temperature drops, they're just going to keep pulling because
that's correct.
Without a human intervention, they're just going to keep pulling more electricity.
Right.
Also, as everybody else is using more electricity, there's a possibility of rolling blackouts too. So what are the backups? We've talked a little bit about hot water boilers that are fossil fuel fired. What are the other backups? Because letting these buildings go without heat on the coldest day in 100 years is not acceptable. In 2021, it got to -2 in DFW, And that was the coldest it had been in 100 years in Texas. And I think a couple of homeless people died in that cold front. And that's become, a criticism of the whole Texas way of life, that we lost a couple of homeless people and it was the coldest in 100 years. If it gets down to 0 in New York City, it's not going to be a couple of people dead if we've switched all this electrification, right?
And damage to buildings. You could freeze pipes.
You can freeze pipes, you can burst pipes, you have frozen water everywhere. It could be really bad. And what we found out in Texas was none of our infrastructure was rated for -2. I don't work in the electric power industry anymore, but I did before I came to Preferred. And I talked to people that still work in that industry, and I said, what went wrong? And everything went wrong. Every technology failed at -2 degrees.
At -2.
Even natural gas failed because the lines froze, the valves froze.
Mm-hmm.
They're all
Really?
outdoor lines, yeah. Outdoor lines without insulation. Nothing was designed for that temperature.
Wow, that's crazy.
So, we see that heat pumps have two big Achilles heels. They don't operate well below about 5 to 10 degrees or so, and their consumption goes up massively at those temperatures.
Right.
So we need to be thinking of what's our plan.
You really don't want to operate them down to 0 degrees,
So
you probably want to shut them off and go to the hybrid, just use your gas or your oil.
yeah, so is it possible plan B is people just keep the infrastructure they have now? And on that, super cold front day, we go fire up our ancient technology boilers and
Yeah, so
use
you
them to heat the
can
buildings?
automate your system, or you can do it manually, but you can always switch over. If you do the hybrid approach, it's a beautiful thing. You can use that when your temperature, say you just want to operate your heat pumps down to 10, 20 degrees. You can always just switch over now to your gas fired and just operate them instead of using your air source. And then you don't have to worry about, pulling so much electricity or peaks.
And the building automation system can be programmed to do that automatically.
It can do that automatically, yeah. That could be fully automated. That's something that it can do.
So are we reaching the conclusion then that there's always going to be some sort of fossil fuel backup for the worst days?
I mean, for buildings, I would say that you would need fossil fuel backup for reliability, or you're really exposed to the couple of key issues that you pointed out, which can really affect your building, major effects on your building. So I think the two options you really have is keep your existing infrastructure, which you most likely have a boiler that's using gas or oil. Going with any other electric, you're exposing yourself. Also the hybrid approach, you now have some flexibility. Say electric goes expensive, you can burn gas, or if gas goes expensive, you can use the electricity down to a certain point, which we discussed. But it gives you some more flexibility and reliability for your building, so that you don't have that case where, essentially you're going to freeze your building, or you don't have any heating for your building.
Preferred did a cool project years ago where a customer was charged a peak rate on their natural gas. So we watched their natural gas flow meters, and if they got close to getting into that next step in peak charge, we used a little bit of utility boiler experience, and we automatically switched their boilers over to oil firing, get them off of natural gas until midnight, when it reset again.
Right.
And then they would switch back to natural gas. And that was a cool project. And it was cool seeing utility level automation on somebody's heating boiler, a big heating boiler, I'm saying, was at a university.
I mean, do you guys see any other technologies that are using, I know there's like tri-fuel boilers, but I know they're not really selling.
Yeah,
they do make heat pumps that do go lower temperature. So they do make, they use carbon dioxide, so CO2, as a refrigerant. And they're just a higher pressure, like I was talking before. And they do get down to those lower temperatures. They're just not as good at cooling. So say you wanted to use your air source heat pump mainly for cooling, and then you get some heat out of it, but then you have the backup, you have the hybrid approach. Say you wanted to just use them for heating, you would need a chiller now separate to handle, well, not separate, but you need some sort of pony chiller or some sort of supplemental chiller in order to get your peak capacity for your cooling. But those lower temperature carbon dioxide refrigerant air source heat pumps do get you down to those colder temperatures, and they are more efficient.
Okay. You said that that technology is advancing.
It's advancing, yeah.
Okay.
Yeah, they use it a lot, like obviously in colder climates like Canada, some spots in Europe, they've been using it. The technology has been around for a while. They're just more expensive. So like for a normal building where they really care about capital, right? They have to raise funds in order to fund these projects, which are millions of dollars. Installing those kind of is not feasible because they just don't have the capital to do it. So that's kind of the technology has to advance from a capital standpoint, or people need to start purchasing them in order for them the prices to start dropping on the units. Yeah, so just another topic. So I talked about the water treatment facilities, but they actually make these things called shark units. I don't know if you guys have ever heard of them, but
No.
Essentially before you send out your sanitary and your storm back to the sewage system, you can install a tank. And all this tank does is it stores it for a little while before it goes to the sewer. And what you do is you connect it to this pump that essentially grinds it down and makes it all little fine particles, and then you send it through a heat exchanger, and that heat exchanger serves a water source heat pump. So you collect the heat from your sewage before it goes out to your main sewage line. So they've been doing that for new buildings a lot because it's such a great way to
Almost
capture
free,
energy.
yeah.
It's free, yeah. You're just wasting all that heat is going into the sewer when you can be collecting it and sending it back into the building. So they can connect them to domestic hot water systems, which is a year-round load, and then they also connect them to your heating system. And a lot of heat pump technologies rely on lower temperature systems. So what I mean by that is your hot water systems, they can't be at a high temperature. A lot of old buildings, they're operating their hot water systems at about 200 to 180 degrees. We need to drop that. Heat pumps don't like to make those higher temperatures.
That's been a trend for about 15 years, is lowering those temperatures.
Lower them.
Because you get
Lower them.
less delta P loss or less delta T loss in the pipe on the way there.
So if you're a building owner and you're replacing your coils, or you're thinking about replacing fin board radiation, or whatever you guys have that's getting the heat to your spaces, start thinking about sizing those coils for lower temperature. And I would size them for an entering water temperature between 120 and 130 degrees. That's what we're seeing from these air source heat pumps. That's what they really like. They really like making between like 130, 135 degree temperature water. They don't do well when they're making higher temperature water, and a lot of them don't even go up to that temperature. So AirMech makes one that goes up to about 149 degrees. I know the CO2 air source heat pumps, they go up to about 180, which is like the max for air source heat pumps. But like we were saying again, they're very expensive, and not many purchasing them because of the capital cost. So I would say if you're going to replace any coils inside your buildings, think about lowering them down, lowering the temperature of that entering water going into them. That's going to be a key component to switching to electrification, is lowering your temperature, your hot water temperatures loop.
Which has been the trend anyway for fossil fuel fired hot water boilers anyway.
Right. Yeah, from steam, if you have steam, you got to switch to hot water. That's your first step, is switching to hot water, and then trying to get that hot water system's temperature down.
Much lower than what we used to run in the past, for sure.
Yeah, that's the main thing we see is a lot of these buildings, they want to go electrification and use the air source heat pumps, but they don't realize that you need to do some extra work in order to get there. So like if you just replace your air handling units and now you want to go electrification and you size those coils for what the traditional the boiler system that you have there, say 200, 180 degrees, now you just really have to replace them because you need to go lower.
So what about the lines getting that water throughout the building is there enough safety factor in the existing lines, or
That's something you
typically
have,
to replace them?
it's something you have to evaluate. Sometimes you get some thicker coils with more rows, so you can kind of eliminate the additional flow that you would need for the lower temperatures. So that's something that would have to be evaluated during design. But try to get a similar coil just with a lower entering water temperature that has the same amount of GPM that the original, the existing coil
So then
does.
your existing lines would be okay.
So that your existing lines will be okay, your existing pumps will be okay. And then you don't have to replace, you don't have to do major infrastructure changes on your hot water loop.
That makes sense.
All right, so I think we kind of we talked about this hybrid approach already, and I mean, it sounds like the hybrid approach with, you know, some heat pumps and then maybe mixing in, you know, if I know there are some locations that I work with that have absolutely no access to natural gas in you know, some of the areas of New York where they are still reliant on fuel oil or some kind of biodiesel low blend. But I mean, if you could go heat pump and biodiesel or heat pump and a very efficient natural gas fired burner, that sounds like a sort of the best approach.
I have a question for
Yeah.
you guys with the condensing boilers.
Mhm.
You mentioned to me that you actually make a condensing boiler that can burn natural gas and also heating oil. Can you burn biodiesel in a condensing boiler?
So, yeah, preferred doesn't do any of that, but well, we do large. Like I know Johnson boilers
There
make
are-
some
there are
boilers that
companies
condense.
do
Yeah,
Condensing boilers that are oil fired. There's a few.
it's small.
I don't see any technological reasons why you can't burn biodiesel in those, but it's probably a matter of the burners and the
Yeah.
boilers just haven't gone through UL approvals yet.
So you guys make a burner that does, like
Yeah.
normal number 2 oil with natural gas that will.
Yeah,
that's
50 horse up. Well,
The burners really don't care that they're on a condensing.
right. Burners don't care at all.
They don't know what's inside the tubes.
Right.
The real difficulty with condensing boilers is you're condensing in the stack. So
Right.
the products of combustion are acidic, so you have to make the stack out of very special materials.
Right.
But I don't see biodiesel being any more acidic than the number 2 diesel, maybe even less so.
I would
So
assume
it would be less,
I
yeah.
would think
Yeah.
it's less.
And the burners can burn biodiesel, so I think it's just a matter of people generating the demand. Once the demand is there, the burner manufacturers like Preferred will go through the UL approval process. Because Robert is starting to go into it before we cut him off. UL approval is onerous and very expensive. It's like a tax.
Yeah.
So every time you do something
Yeah.
new, you have to pay a UL tax.
Right.
And there's just no point in doing it until there's a demand. You know, we have to see that people are going to buy these before we can spend the money to go through UL approval. But from a technological point of view, they're all right.
Okay. Yeah, because mostly all my clients that I work with, they want to switch to condensing because they want to get that little extra efficiency out of the
A lot
boilers.
efficiency.
And if you start dropping your temperature of your hot water loop, now you're talking even better efficiency because as the return starts to drop, the
Yes.
efficiency of your boiler starts skyrocketing.
Yes.
I have seen boilers fitted with condensing economizers where the outlet air temperature of the condensing economizer is below ambient temperature on a hot day in Dallas. So does that mean it's more than 100% efficient? You know, if your stack temperature is lower than ambient, it's pretty amazing technology.
Wow.
And it's been around forever.
Yeah, I mean, saving 10% on your utility, say if you're just operating a condensing boiler, and this is even just a multifamily building that's 150,000 square feet, 10% on your bills is a lot of money.
Yeah,
That's a lot
it's
of money.
huge. It's not all positives for condensing boilers. If you don't keep up with your water treatment, they're not going to last very long. They almost become a consumable.
Right.
So a lot of the condensing boiler inquiries I see, they want to buy exactly what they have there now because it's just like replacing an appliance, and there's very little plumbing that goes on if you replace exactly in kind.
Mm-hmm.
But especially if you have poor water quality, you're going to be replacing condensing boilers a lot more often than a normal boiler.
Right. And the condensing boilers, you need the stainless steel.
It's a special material, and I don't remember the number for it.
AL29C.
They use
There you
it.
go.
Are they allowed to use that in New York City?
Yeah.
Because PVC's banned.
PVC's banned, but they use the AL, or you could just use. We represent lifetime chimney, and they use, I want to say it's 444 or 304 stainless. A lot of people just
I
use
just
the
do the stainless
stainless.
just to be safe.
Stainless is it's the best way to go. And if you do, I mean, what we recommend, we have like a male female connection. And if it's pitched properly, the male will go over the female end, and you'll never get the if you use a traditional like V band or like a flange connection.
Mhm.
What happens is it'll sit and in the like the flange connection, and it'll actually eat away whatever silicone or whatever you have there, and you'll get leaks. And I have one where we're going to be replacing it where the leak started right above the boiler. It ate through the silicone, it ate through the insulation and the outer wall, and dripped on. It kept dripping on the boiler. It ate through the top of the boiler. So it's really nasty stuff. So yeah, we just stainless is what you use.
I feel like efficiency improvements, though, were the answer to carbon reduction in the past 20 years or so. I feel like we've kind of moved past that. Like it's not enough anymore. Condensing boilers, the efficiency gain you get from that, LED lights, everything else, it's just not enough anymore. To meet the 2030 targets, you need to do more than just efficiency improvements. You need to change the way you're heating your building.
Yeah, I mean, that's an evaluation you have to do per your building, but I think with the hybrid approach, you would hit most of those goals that New York City is putting out for local law 97 for most buildings. I think you would be.
Yeah.
I think everybody's end plan is to move out of New York City anyway, right?
And you know what? The condensing boilers and the heat pumps, they work really well together. Because you drop that temperature. You drop that temperature of that loop.
Same water temperature. Right?
Yeah, so they both like that, right? You're getting like maximum efficiency from both of them.
Yeah, those two technologies are really compatible together.
And then it gives you flexibility,
Right.
still using the condensing boiler.
Right, flexibility, and you have that as the backup in case something,
What other option is there to an e-boiler? I mean, you could install an e-boiler, but then you're pulling a tremendous amount of electricity.
Yeah, we've seen that work outside of, I'll say, maybe major urban areas. Like,
yeah, I guess if you don't live in New York,
yeah,
it depends on the cost of electricity.
Absolutely.
Like there's some areas where electricity is cheaper than natural gas.
Mm-hmm.
It probably makes sense to install an e-boiler with the air source heat pump.
Yeah.
But here in New York, it doesn't make financial sense.
Right. So I mean, yeah, it's definitely a case by case, and region by region analysis that has to get done. But there are options out there. The heat pumps have come a long way. And if you do a hybrid approach that, takes away the one, con that sort of goes against heat pumps, which is the reliability in a peak high demand time. All right, so just kind of recapping what we had just talked about regarding the hybrid approach. Obviously, you got to look at it from a holistic, point of view. Where you are in the country, and what is available to you as far as the utility, electricity, your natural gas prices, your fuel oil, and how cold or hot your region can be. And there are different approaches, but it seems like we've sort of all agree that the hybrid approach is probably the best, having a backup, especially up in our region here in the Northeast.
What I took away from this is contact Patrick if you have more questions.
That's absolutely. That's why he's here. So thank you guys for joining with me, David and Patrick. And we will be opening it up to question and answer time, and we would appreciate any questions that you guys have. Thank you. All right, good afternoon. Yeah, this is Robert Bond with Analytical and Combustion Systems, and I'm joined here with Patrick again. So we are, if you have any questions, if you want to put them in the chat there, we'd be more than happy to. I see we got one question from Matt. Are you seeing biodiesel allowed in jurisdictions where electrification is pushed or mandated? And Patrick, we are seeing that in New York. It's definitely allowed, right?
Yeah, it's definitely allowed. There's just there's more of a push for electrification.
Right. There's no real incentive.
There's no real incentive to use the biodiesel, but yes, you can use biodiesel as a source of heating.
Yeah, and you and I talked about this about New York State, seeing basically they see even if you're firing B99, they see B99 just the same as they see number 2 diesel, even though the reality is you are being better on your emissions by using a biodiesel.
Right.
But they give you there's no credit, no incentive. So that's sort of what we're seeing here, in New York. Who should we contact to get the PDF of this presentation? That would be Megan. You should have her email. And then if not, you could always reach out to me. My email, I believe, is in the beginning of the presentation. But yeah, Megan would be the best. If there are any other questions, yeah, just let us know. I know something Patrick and I were talking about just now was that what we were just looking at the charting of the price of B99, B20, and number 2 diesel over the past 10, 15 years, and how they all track very closely to each other, with B20 almost being right in line with number 2 diesel, and then B100 being slightly above on the price per gallon. But they all track, fairly closely to each other. And then the nice thing is if you do have an end user or you're looking to design for an end user, if they want to design for B99, then once the capital cost is put in and you have the correct pump set, the correct burner, the correct piping and valving, now that customer is set up to essentially play the market when it comes to fuel. They can put in B99, or they could put in diesel, or you could put in really any biodiesel that you'd want, because you'd be set up for it. If you're just set up for diesel, you can't necessarily go to a higher blend above B20 due to some of the issues with yellow metal valves and how it reacts with biodiesel. Let's see. Tim says, I get a slight rebate on the residential side for using biofuels in New York State. Okay, that is great. I was not aware of that. I'd be interested what blend, or how much of a blend of biodiesel is going in on the residential side. I know there are some great advocates for biodiesel that are out there. I know there's a group called NORA that does lobby and advocate for the use of biodiesel, especially they're focusing on the residential side, obviously, which is the bigger part of the market. A lot of us up here use oil for our heating in our homes. And they are definitely starting to blend more and more biodiesel in, which is good. All right, Jay, which costs more to operate during the winter, heat pump unit compared to a high efficient gas-fired condensing boiler? I mean, there's a lot of factors there. It definitely depends on the price of your electricity versus your gas, right? I mean, I'd say.
Yeah.
And,
yeah.
I mean, that's definitely.
And it also depends how low you want to operate your heat pump down to. So like we were saying, the lower the ambient temperature is outside, the less efficient your heat pump starts to become. So maybe financially on your utility bill, it doesn't make sense for you to operate your heat pump down that far.
Right. So I mean,
I guess what we're saying is it depends on your utility bills, what you pay for gas and what you pay for electricity. But most of the time there is some point where switching to gas would make financial sense on your utility bill instead of using the heat pump that's using electricity.
Which, combine all that together, is the hybrid approach, which is sort of what we're talking about, which is the heat pump and maybe not a gas, depending on your gas supply, gas or some kind of a biodiesel. Yeah. All right. If there are any other questions, yeah, just let us know. I mean, you could, and the other thing is, you feel free to email again Megan with any further questions. You know, we have Patrick's email on there as well, and you know, he and I talk frequently. So if you have a question, feel free to reach out to Megan, myself, Patrick, or David Oaf, and you know, we'd be more than happy to get back in touch with you. And yeah, we appreciate, you know, everyone that's joined today, and we look forward to hearing from you.
Thank you, guys. Appreciate it.